First, a comment. We found for some chemicals, of course, the microbiome can be very important in terms of toxicity as the first place of metabolism, and that microbiomes are colony specific. So while Sprague-Dowling rats in the US and Europe are apt to be genetically quite similar, their microbiomes may be extremely different. So it might be useful if you can get enough funding to have rats from different colonies for the microbiome part at least. The second, oh, sorry.
Oh, no, please.
My second issue, in addition to diversity, we've also seen that sometimes diversity doesn't change, lack of diversity doesn't change functionality, though it may change resilience to changes. But what I'm more interested in also is that in normal foodstuffs, we get replacement microbiomes, even if we're not eating specifically for that. All food have bacteria, as we know, other things on them. But the rats are presumably getting rat chow of some sort, so there wouldn't be the diversity of the microbiome. Do you have any plans, or could you think about having, another group where by feeding them natural foods, they might have a different result on the microbiome than if you just change it with the pesticide and they can't have an outside source?
So, starting from the first question, indeed it's important to address different strains, and the reason why we want us to start also from the Sprague-Dowling is because Sprague-Dowling, there's still a debate, but tend to be predictive also in terms of microbiome alteration rather than, for example, models that are completely pathogen-free or with microbiome that are specifically designed for modeling the study of single strains, because it's a more human equivalent model where the diversity of the microbiome is present, while in certain microbiome design experiment, the decision, for example, to implant human microbiome in knockout mice might not be as predictive or as relevant for human counterparts. I'm not talking about informative, but predictive at least for the health outcomes. Secondly, is for sure there is a role in the diverse strain in terms of not only for the numbers and for the heterogeneity, but also for the functionality. And this is where the long-term setting will tell us, is there any detrimental health outcome that happens and occurs downward after these changes in the microbiome happen? Because that's still a challenge in the microbiome world to address whether these alterations are connected with a specific outcome. And it was associated with obesity, with diabetes, with many outcomes, but indeed we want to make sure that the outcome downward might be connected with an alteration of the microbiome. So a priori is not good in general to see an alteration of the microbiome, but also, and this something we specified also in the paper, we have to see whether this alteration of the microbiome will be associated with toxicological endpoints in a long-term setting. The last question was on the food. That's actually, that's why you have a control group there with similar exposure, because yes, you can make or use, for example, organic food, or you can use food that is more controlled for biological and microbiological exposure to rats, or create more specific conditions. But no matter how many specific conditions you create, you hardly recreate whatever exposure really occurs in humans, which might be thousands or millions of different exposures occurring every day. So I rather say we just count on the control exposure as a statistically significant difference there, specifically when it's a P lower than 0.01 that we observed in the first paper. We are quite confident this might be relevant for humans in terms of alteration. In terms of outcome, we have to address that in long term.
Thank you.
Please?
I guess I'm a little nervous about the microbiome as a focus of your research. We know so little about the relationship between changes in microbiome and physiological changes, whether it's obesity or with pathogens, that it's very controversial. And not only that, but so many people associate changes in the diversity of the microbiome with, let's say, with disease, that they miss the point, that the organisms can be there and be, as an earlier questioner said, maybe they're not functional. If we don't focus on function, then diversity doesn't mean anything. So it's a dangerous conclusion.
I fully agree with that, and I just want to, make sure that the microbiome alteration is an endpoint of interest, but toxicologically speaking, the key endpoint of interest for us were like reproductive, endocrine, carcinogenicity, genotoxicity. Speaking of toxicology, for the value and the importance of microbiome alteration downward in an health outcome, this is what we need a long-term study for. And actually, it's so much so that I know that also NIH made recently a call on connections between health outcomes and microbiome alteration because of the lack of evidence so far that connects specific alteration or certain alteration with health outcome downward. So I fully agree with you that one thing is association, and coming from the cancer world, I can't agree more with you. There are 1 gene per day that have been associated with cancer, and indeed things like asbestos or benzene are forgotten as a cause of cancer in spite of some fashion gene that emerged that very day. So if it was not clear before, I want to make this point now. Microbiome alteration doesn't mean detrimental outcome per se. What means a detrimental outcome is anogenital distance or in alteration in target organs or alteration in endocrine endpoints that have been already demonstrated to be connected with effects in humans. Please?
I was wondering if you could make a point related to the biomonitoring. So you decided that you, in the tox study, you're going to dose the animals, you know exactly what the dose is, you have control of the dose, but you also wanted to demonstrate what your analysis showed by way of exposure. So, you found some very interesting patterns, with AMPA being less prevalent, the parent being more prevalent, but also evidence of some bioaccumulation. And so I wanted to ask, were you surprised by how little was known in the methods used to detect this compound in urine, in animal urine or in human urine?
Yes, that's a story within the story, because so many claim that an excellent method to measure glyphosate, and one of the hardest part was finding a lab that was actually measuring glyphosate level with appropriate methods and consistent methods, because many claim very few could measure the level of glyphosate that are really what we find at environmental exposure in humans, but also the levels that we wanted to test because these were the relevant ones. And these techniques we just did some testing also with Melissa in cohorts in humans, trying to use the same methods to address the exposure in human cohorts, and we have some interesting results, I believe, especially because the cohort was starting from 1996 and glyphosate was already there. But the part that I believe is more relevant for human is, first of all, we don't have to take for granted that bioaccumulation is not happening in humans or is happening in humans. We have to observe. I believe settings like Haynes or similar studies are the best setting to observe also how this occurs. There is evidence that there are increasing level in urine of glyphosate, for example in Germany, measured in the general population. But whether this occurred for bioaccumulation or for increased exposure or because of both, that's still up to debate, and the evidence are very few. Secondly, the methods are really, believe me, heterogeneous. There's one test that a lab in Italy did, sending to 10 different laboratories in the world, expert laboratories, like top-tier laboratories, 10 samples of the same matrix of corn with a known level of glyphosate, because they directly put the glyphosate on the corn, and the results were extremely heterogeneous, like 10 times differences among labs. So this is tremendously important, and the way we tested, for example, for accuracy was sending twice or 3 times the same sample to the lab, or just checking the control levels and saying, you know, there was glyphosate exposure there when we knew that there was no glyphosate exposure, just to check. You know, that's the way scientists should do. You know, check your hypothesis, trying to, as Popper said, disproving your hypothesis. You know, whether it's falsifiable or not. So we try to falsify as much as possible our hypothesis. But yes, it's important to establish solid methods for this.
Yes, great talk.
Did I answer your question? Okay.
Yeah, great talk. Thank you very much. I'm really going to challenge Shemet's ability to crank the. I'm going to make it harder for you too. So, my question is related more to exposure. The earlier parts of what you said. One of the first things you mentioned was that Europe has banned GMO, and therefore, I don't suppose you're taking many shipments of our corn. Therefore, I'm left to wonder, how are people being exposed to glyphosate? Most of the corn, even grown here in the U.S., isn't consumed by humans. It goes to animal feed and biofuels. So is it mostly runoff getting into our waterways? Is it a residual even in the animal fats that perhaps we're eating? And you already started to allude to the complications of sampling for it, so maybe that's part of the relationship. How much do we know, I guess, about the exposure to glyphosate?
So, as a source of exposure, water, except for the occupational setting where indeed it's a direct exposure to glyphosate, but food and water seem to be the main source, and actually it was measured in food in the US and in Europe. A big scandal in Europe was Germany beer. In Germany, the beer that was, not surprisingly, since what is the prime material to make a beer, there were measurable level of glyphosate there. Not to mention what happened with pasta in Italy.
Oh no, don't take that away.
But it's also important to be balanced, because the level of exposure that we measure many times in these matrices were extremely low. And again, it's important to know how this measure is made. So appropriate measurement by HPLC are not the same as ELISA, for example, in particular for glyphosate, which is an analog of glycine. A lot of false positive might occur. So the burden of exposure seems to be, for the environmental exposure, attributable to water, where in Italy, for example, 45% of the water was known to be contaminated by glyphosate. But the doses are extremely important in toxicology and in epidemiology. So what we have to know is the exposure having, this kind of exposure having an effect in humans and having an effect in general, both in the occupational setting and in the general population setting. This is, I believe, what is missing and what we try to measure with our, first the pilot, but then also long-term study using human equivalent exposures.
Under human equivalent exposures, one thing that is interesting from the Institute of legislation didn't pass the Senate, we should cut back on IROC's funding. Have you experienced any sort of pushback or controversy around this work, and how do you respond?
I mean, we are used to work on asbestos, benzene, formaldehyde, so
Something
yes.
controversial.
I believe since the time of Maltoni that's something we are a little bit used to, but also the NIH is under pressure often and frequently from stakeholders or parties of interest. What I believe about the controversy that surrounded the hierarchy evaluation is that there was a lot of opinion, a lot of discussion, but a couple of data that are important were missing from the debate. One is the fact of glyphosate-based herbicides versus glyphosate alone, which is something that is also very useful for a future hierarchy evaluation. And the other aspect is they classified based on limited evidence from humans on non-Hodgkin lymphoma, based on sufficient evidence from 2 strains in animals. But the evidence, although might, I'm not a risk assessor, so I leave them the decision. But let's say in the realm of hazard, that was a decision that could be made. But in the realm of risk, still the things were extremely complicated because of the doses, where the doses being 175 milligram per kilogram, most often higher when the carcinogenicity bioassay have been performed. Or there were studies where the number of animals and the design was, let's say, not consistent with NTP guidelines, for example, that observed increased tumors, but were not as solid as in the design as a standard NTP study, for example, would be. So I believe the evaluation in terms of hazard was at least transparent and accurate, but in terms of risk, I still think that data are missing. So there was tension because of conflict of interest discussion, transparency discussion, which are in the political realm or the media realm of the discussion. But in terms of science, I believe none of us should be happy with the evidence present at the moment. And having more evidence is something that the PEST Committee of Europe demanded just today, 2 days ago. because there is lack of evidence. It's not that somebody is hiding, or if somebody is hiding, we don't know, but there's no disregarded published evidence, to my knowledge, at the moment.
How were your results received by the EU Parliament? I believe you said you presented earlier this year, and you said they extended their, EFSA extended glyphosate or Roundup through 2022, so I was just wondering how.
With Britain and
So
without.
as a-
Recommended, okay.
As a time frame, the relicensing of glyphosate happened before our
Sure, yeah.
our presentation. But what happened with the Parliament was that they responded extremely well and almost beyond our expectations, I have to say. And I really hope that also this document that the European Pest Committee presented will move towards a more consensus evaluation of the pesticide, because where this pesticide committee inception was based upon was on 1 million European citizens that protested, let's say, the assessment by EFSA. And I also know a lot of colleagues at EFSA, and they do an excellent work, and I believe it's also in the best interest of any institution or regulatory authority to have the confidence of their own citizens and their own public. So I believe the steps proposed by the PEST committee, which are mainly increased transparency, more attention to public health compared to commercial interest, for example in the disclosure of the ingredients, are very reasonable points that can be agreed upon with all the stakeholders, or at least I hope so.
With that, Daniele, we're past time, so thank you.